Hi everyone, welcome to homework 1.21. So today we looked at graphing inequalities, which is the same as graphing equations, except that we're going to be shading one side to determine whether it's, depending on whether it's greater than or less than. So for the first question, it gives us the graph of the equation for 2y minus x equals 1. And so we don't need to convert this into slope-intercept form because they already graphed it for us. And so we'll assume that they graphed it correctly, right? It says, are the points 0, 1 half and negative 7, negative 3 solutions to the equation? Explain how or show how you know. So looking at 0, 1 half, I see that that is a point on my line. And likewise, negative 7, and then down 3 right here, negative 3, is also a point on the line. So I would say yes, because they appear to be points on the line. Now the other way that you could test them for sure is to go ahead and plug them into that equation, right? So if I were to plug in 2 times 1 half, because y is 1 half, minus 0 equals 1, 1 does in fact equal 1, so that works out. You could also do 2 times negative 3 minus negative 7 equals 1. This is negative 6 plus 7 equals 1. That is true. So we can also prove algebraically that those are points on the line. Letter B says, check if these points are solutions to this inequality. So if we take this and instead of the equal sign we put a greater than sign, are these points accurate or not? So let's look at the first one. The first one says 0, 2. So if I plug in 0, 2, that would be 2 times 2 minus 0 is greater than 1. Well, that would be 4 minus 0 is greater than 1. Yes, that does work out. So 0, 2 is right here. And so that is a point that checks out, that works. I'm going to put a check. It's a good point. 8, 1 half. So if we plug that in, we get 1 half times 2 is 1, minus 8 is negative 7 is greater than 1. That is not true. So this point, 8, 1 half, which would be approximately here, is not a point that works. Okay, so no. Then negative 6, 3. So if we plug in 3 for y, we get 2 times 3 is 6, minus negative 6 is greater than 1. That's 12 is greater than 1, so that is true. So negative 6, 3, which is about here, check, that works out. And then last but not least, negative 7, negative 3. So that was this point right here that we determined. And when we plug that in, we end up with, and we saw that right up here, we get 1 is greater than 1. Now 1 is equal to 1, but it is not greater than 1, so this is not a solution. This point right here, which is on the line, is not a solution. Okay? So it says shade the region that represents the solution set to the inequality. Well, if you look at my graph, all of the points that I put checks on are above the line, and this point below the line is not. So we're going to shade in above the line as solutions. Those are solutions to our inequality. So we've done that. And then letter D says, are the points on the line included in the solution set? So no, because it is greater than, not greater than or equal to, right? So in order for the points on the line to be included in the solution set, it would need to be greater than and equal to. So this should actually be a dotted line instead of a solid line for the inequality, right? Again, they graphed the equation, but to graph the inequality, we would make that line a dotted line. All right, number 2 says, select all coordinate pairs that are solutions to the inequality 5x plus 9y is less than 45. So for this one, all you're doing is plugging in x and y to the equation and seeing if it works. So if we plug in 0 for x, we get 0 plus 9 times 0 is 0 is less than 45. 0 is less than 45, so check, that one's good. B, if I plug in 5 times 5, that's 25, plus 0 is less than 45. Yes, that is less than 45. Very good. If I plug in 9, I have 9 times 5 is 45, plus 0 is less than 45. So 45 is equal to 45, but not less than. So that is not true. That is not a solution. 0, comma 5. Now we have 5 times 0 is 0, plus 45 is less than 45. So we have the same situation here, and so that is not a solution. All right, so that's all you're doing is you're plugging in x and y values where you have x and y in the equation and seeing if it's true or not. So you try E, F, and G on your own. I'll give you a hint that the remaining ones, 2 of them are not solutions and 1 of them is. All right, let's look at number 3. It says consider the linear equation 2y minus 3x equals 5. And it says the pair -1, 1 is the solution to the equation. Find another xy pair that is a solution to the equation. Okay, so one way that you could find a solution is to graph it and find something that is on the line, a point that is on the line. But I can also reason that one way that I can subtract to get to 5 would be to say 8 minus 3 equals 5. And so to get that, I would say, well, y then would have to equal 2. And x would have to equal 1. So another, sorry, not 2, 4, because to get from 2 to 8, we would have to say 4. So another point that would work would be 1, comma 4, where x is 1 and y is 4. All right, let's take a look at letter B. It says, are -1, 1, and 4, 1 solutions to the inequality 2y minus 3x is less than 5? Explain how you know. Well, again, we can plug these in and see. So if I plug in -1 and 1, we know that that is going to be equal to 5. But let's go ahead and show that. So 2 times 1 is 2, minus 3 times -1 is less than 5. We get 2. And then a -3 times a -1 is a positive 3, which is 5. And that is not less than 5. It is equal to 5. So no to the first one because it is on the line, right? It's on that boundary line that we talked about. All right. For the second one, 4, 1, let's plug that in. So 2 times 1 minus 3 times 4 is less than 5. We get 2 minus 12 is less than 5. We get -10 is less than 5. And that's a yes. So yes, 4, 1 is a solution because when we plug it in, we get a number that is less than 5. All right, letter C says, explain how you use the answers to the previous question to graph the solution set. So we know that 0.4, 1 is a solution. So we would shade that side of the graph. Sorry, my son has entered the room. You may have heard him heavily breathing. But he's joined mommy in this video making. All right. Number 4. So on the next page it says the boundary line on the graph represents the equation 5x plus 2y equals 6. All right, so that's this line right here. That's our boundary line. Now it says write an inequality that is represented by the graph. So we need to figure out, instead of this equal sign, what am I going to fill in there? Well, a point that we know works, they shaded this side. So a point that we know works is 0, 0. So if I plug in 0, 0, I will get 5 times 0 plus 2 times 0 equals 6. That's 0 plus 0. And then remember, we're looking for the inequality sign now. So 0 in relation to 6 is less than. And so that means for this inequality to work, it would be 5x plus 2y is less than 6. All right, so again, reviewing that, if I want to figure out what I'm replacing the equal sign with, I look, this side is shaded in, so that means any point on this side should work. And I could pick a different point too. So let's say I picked -1, -1, right? If I plug that in, I get -5 minus 2 right? Trying to find the inequality sign 6, we get negative 7, and that is less than 6. And so we know that the inequality we're looking for is the less than sign. All right, similarly for number 5, we have 4 equations here. Now, we can eliminate some things because we have a dotted line, and a dotted line tells us that we're looking at a greater than or less than. So it can't be B. Oh my, I'm not sure what happened there. Okay, it can't be B, and this computer's really messing with me today. All right, can't be B. I don't know why it's doing that, but can't be B and it can't be D. Okay, I'm going to stop crossing things out because clearly that's not working. So it can't be B and it can't be D. It has to be A or C. And we need to decide if it is greater than or less than. So let's go ahead and test a point that we know works. Again, 0, 0, the origin works because it's in the shaded area. So if I plug that in to this equation, I would get 0 minus, it is really just doing 0, maybe if I try writing down here, 0 minus, okay, 3 times 0 is what to 5? So in this case, I would get that 0 is less than 5. And so that means that this does in fact work. Okay, so that's something that can work. So if we know a point that is in the solution area and we test it, then that can help us determine what sign we're looking for. If we were to test this point in another equations, right, let's say we test it in C now, and we say 0 minus 3 times y is 0 is greater than 5. 0 is not greater than 5. So we know that that one is not an equation of the graph. Okay? All right. 6 is a review. It says Maya and Tyler are selling items to earn money for their elementary school. The school earns W dollars for every wreath sold and P dollars for every potted plant sold. Maya sells 14 wreaths and 3 potted plants, and the school earns $70.50. Tyler sells 10 wreaths and 7 potted plants, and the school earns $62.50. It says explain why in this sense it makes sense that the solution to the system is also a solution to this equation. Now, it is not asking us to solve this. It is asking us why is this equation here the same, going to give us the same solution as these other 2 equations and the equations in the system of equations above. So, I'm trying to, let's see if it will let me. Okay, let's go ahead and see if I can add some information here. All right, so I'm going to type this answer just for ease. And so we're going to say this solution makes sense because, now notice, what is this new equation in relation to this equation here? Well, if we were to subtract this equation from the first equation, then we would get this new equation. So this solution makes sense because they subtracted the left side of the second equation from the left side of the first equation, and the right side of the second equation from the right side of the first equation, and therefore the new equation remains balanced and will give us the same solution. So this is the kind of answer that we're looking for when it asks you explain why, right? So when we subtract, as long as we are subtracting equal sides, so the left side from the left side and the right side from the right side, and they are both balanced, then we'll get a new equation that is balanced and will also give us the same solution. Remember too that when we do this, this also gives us a new line. So those first 2 equations, the lines may look like this and they intersect at a certain point. And then the third equation that we create from those intersects those. And so it would also have the same solution as those 2 original equations. All right. So again, this is our nice answer that we would be looking for in making sure that we are explaining fully why we would get the same solution. All right, number 7 says Elena is planning to go camping for the weekend and has already spent $40 on supplies. She goes to the store and buys more supplies. Write an inequality that represents D, the total amount of dollars that Elena spends on supplies. So we're looking for D. Now, we don't know what D is, right? We don't know how much she's spent yet, but we do know that the total amount that she is spending is going to be greater than $40. So we could say D is greater than 40 because we don't know exactly how much she has spent on the supplies. We just know that she spent 40 or more because she spent more money. All right, letter number 8. Number 8 says solve this inequality. And so for this one, there's a couple ways that you can attack this or approach this. What I would approach this with is go ahead and multiply it by the least common multiple of 6. All right, I'm going to break this down because this would then be 6 times x minus 4 all over 3 is greater than or equal to 6 times x plus 3 all over 2. Now you can go ahead and simplify this, and that will become 6 divided by 3, which is 2. And on this side, we'll get 6 divided by 2, which is 3. And so this then becomes distributive property, and we get 3x plus 9. There's 2 ways that you can approach this. You can subtract the 3x from both sides, and that'll give us a negative number on this side, or you can subtract 2x from both sides, which will give us a positive number on this side. You will get the same answer either way, as long as you remember what to do with your signs in certain situations. So this is negative 8 is greater than or equal to x plus 9. Subtract 9 from both sides, and then we get negative 17 is greater than or equal to x, or x is less than or equal to negative 17. All right. Your very last problem is very similar, and I'm going to start it for you, but then I want you to finish it. So you're going to go ahead and to get rid of this denominator of 3, you're going to multiply the whole thing by 3. Now remember, that's ultimately going to be 3 times 4x minus 8 all over 3 is less than or equal to 3 times 2x minus 5. All right, this 3 over 3 will become 1, and so you'll be able to cancel that out. So that's what I'm giving you up to that point. I'm going to be looking to see that you got an answer here and that you continue to solve it. All right, your code word for today is building blocks, because when my son came in to interrupt me, he was holding some kind of building block. Thank you so much for listening. Happy homeworking, and see you tomorrow.